So in this video, I'll continue on from lecture 2 into how do we actually start doing research, right? We'll talk about research methodology, and I'll first begin with how should we actually approach research, right? I'll do this by first talk about this typical research cycle, which you first look at hey, I want to work on this area. Maybe you go to lectures like, hey, this topic is really interesting. So let me dive deeper into that. To do that, you would first identify some key problems that you want to work on, followed by developing some hypothesis, which would give you the link between the problems to the goal, right? So that you can develop potential solution. And then once you have potential solution, you have to find a way to evaluate how good is that at solving the problem. Once that's done, then you can evaluate your proposal. Are there anything that are still flawed in your solution? Anything else you can do? Or is the area good to work on? If not, then you might want to find another area. If the problem doesn't make sense, then you can maybe find a new problem that can happen. Actually, to be honest, it does happen to me as well, right? I was working on one of the area. This actually one of my projects when I was an intern at VMware Research. We want to be able to share GPU amongst many users in the cloud, right? And then we discovered that, hey, the problem right now is the GPU is not really good at sharing. In fact, it doesn't even have this ability to do what we call address translation really well. So this is one of the key technique in computer science, right? And if you cannot do that well, you can't share them, which means I cannot share the GPU in the cloud. So that leads to a different problems that to be honest, actually this spawns into actually multiple works that I get to work on, and that those are really interesting in my opinion, right? And if the problem makes sense, then you can keep improving your hypothesis to make sure the mechanism you're proposing is as perfect as possible. And every single step here, right, you require more and more literature review, as well as thinking about previous proposal, as well as your current proposals. And that brings me to the importance of reading paper, because you want to be able to gain more knowledge on a research topic. Because you want to in-depth knowledge, you want to analyze it, you want to be able to discuss the current solution, and you can actually think about what can I do, right? Because that's the key. You want to know what can you do. So to identify what can you contribute, you have to keep thinking and reading. You want to be able to first identify what I'm going to ask you to do for your review, right? Not just the summary of the paper, but pros and cons. What's good about the paper and what is the author trying to hide, right? No paper are perfect. So you want to make sure you can identify the downside of the paper. And if you're not used to reading tons of paper yet, you should do so now. Going forward, as you are working on your own master's thesis, this is basically crucial. And once that's done, let's say today I'm gonna keep covering more on this 6 bubble that I put in here. First, start by talk about identifying key problems, because a good problem can jumpstart your career, right? So that's the first step. The first step is, well, obviously reviewing articles. Why do I say this? It actually doesn't have to be always the first step for some people. Some people have their own existing research problem. I work on some paper, publish certain mechanism, and then I know exactly what's the next problem I want to work on, because the mechanism I propose might not be as perfect as I want to, right? Or it spawned a new problem that I know, right? But now that you're all like new to the area, even for those of you who've been in the job market, who work in an industry before, when you run into a problem, many of the problems are known and solved, right? So you can Google for the solution, but now you're thrown into another realm where you want to contribute something new, where no one fixed it before. So reading more can allow you, first of all, to find the topics that you are gonna like, and then you can summarize what you know about the topic. This is a really good first step. And then you can identify key papers that you can gather around this topic, so that you can see, hey, what are their benefits and what are their downside? it has to be a conglomerate of multiple techniques on certain problems, right? So my guide here is you need to keep reading paper. This sounds actually troublesome, but this is what we do all the time as a researcher, right? You're gonna keep knowing more and more, and that's what's required for good research. Because once you know more, you can explain the phenomenon that you were not able to explain before. And the more you read, the more you're gonna know, right? So the more you can explain and start to develop your own solution. And once, let's say you have a sub area, right? If the related paper are old, this is something you want to question yourself. Like, why has no one worked on it in the last 5 years or 6 years or 7 years, right? Is the problem solved? Because you don't want to work on something that's already been solved, there's a clear solution for. Are there other groups still working on it, right? Are there other related work that help solve the problem already? Or is the problem not important anymore? No one cares about this. Because technology advances, then it's no problem. We're good, right? Because otherwise, it's time to identify where is the knowledge gap, which specific problem are not solved, and what prevent us from solving these problems, right? If you find hard problems, many people will say, hey, this problem is hard, let's not work on it. My take on it is, if the problem is hard, but the problem are important, is actually a great opportunity to kind of maybe flip things around a little bit and see, with scientific knowledge and logical thinking, how can I use that as an opportunity to basically maybe mitigate a problem? It doesn't have to always be solved, right? But can I mitigate a problem so that the problem becomes less hard? And you repeat the same step again and again and again and again until the problem is solved, right? And that's how research, the nature of research is. It's a lot of small steps rather than one huge jump, right? It's a lot of small steps toward the better, I mean, to be honest, like the betterment of humanity. But I mean, at the end of the day, so that you can know more and there's more solution to the problems in the world, right? And now that I talk about the problems, once you know the problem, then you want to identify, hey, what's your goal, right? What's the goal? What do you want to achieve to address the problem? Things like, do you want better performance? Do you want ease of adoption, more people to use certain techniques? Do you want to lower the cost? Right. This is actually one of the really, really important topic in engineering research. With certain scientific solution is too costly. How can we make it cheaper? Do I aim for generality or robustness? Right. So that it works on multiple environments. It works when they have more devices connected. This can be important in many, many areas, right? So it's a lot easier to design whatever you want to design if you know exactly what you want out of your design. So having a goal or a goal that you have in mind is so important. And this is one of the common pitfall as you go and work on your research, because sometimes you lose the sight of where's your goal. You see the problems, you see some solution, and then you get distracted. So make sure you have at least the goal on hand, so you know exactly what you want to achieve. And now that you have the goal, it's time to start to develop hypotheses. Once you find potential problems, you then need to, based on all your knowledge, put things together logically to say, hey, how do I solve this problem? The first set of I guess hypothesis would be something that would move you closer, right? Basically, move you closer to the goal. Why is it important? Basically, it kind of connects where you are right now from the problem to the goal, and it provides the motivation to work on the topic. And here's a step one, right? Here's a step one. To develop your hypothesis, you want to first do an analysis on where is the key source of the problem. This can be a lot of analysis on paper. This can be a lot of evaluation and experimenting in the lab. And this can mean a lot of paper reading. Actually, this is my advice. You have to actually be gutsy actually about this. You have to kind of power through and you have to find the source, because once you have that, you know how to address, well, at least you know the source, so you know what can be done to address it, or somewhat, right? So your first hypothesis should be on building like the relationship between the problem source and the goal, right? And you can basically then you develop these logical steps that based on tools that you can find, including new tools that you're going to contribute to reach the goal, right? And then once you have that, you're going to have to test your hypothesis. And how do you test it? Well, it's experimenting, and a lot of evaluation, right? You can also use previous paper data and experiment as a guideline on how do you want to conduct your own experiment. And it should provide the data to support your hypothesis. And that's really, really a big key thing here. You need to answer the question that you have because data do not lie. Data do not lie. But a poorly designed experiment can give a really horrible set of data that becomes useless for your research. I've seen this many flaws happening many times. I've been rejecting many papers that present data that doesn't make any sense. So don't fall into this particular pitfall. And if you did fall, it's okay, but you need to learn from it and grow from there, right? Everything you do, everything you work on, everything you experiment on, use that as an experience to grow. And that's a big key here. You want to be able to grow and learn from your experience. And when you talk about scientific experiment, right? What are you trying to prove? You need to identify what exactly are you trying to prove, because you have to deal with a lot of things that you have to control, the variable that you're going to control, and the variable you're going to vary so that you can test on multiple values of this variable. So don't just, this is my key point here, and actually it does happen to many students, including students in my group, right? I still need to tell my students, like, hey, don't just randomly run experiment. It's useless, especially if you run the same thing again and again. I mean, it's computer. You run that the next time, so behave the same way. I mean, why can't you be gutsy and like, why can't you actually try to identify what's wrong and then work hard through what do I want to run next, rather than just fire off the same simulation again or fire off the same experiment again. It's going to look the same. Data do not lie. Science do not lie, right? You want to be able to deal with experimental framework. What tools are available? This is basically what you can gain from literature survey. Keep reading because it's going to uncover more and more tools. Be mindful about the method, or sometimes it's called methodology section of each paper, because it would tell how the experiment is done for their own paper. So you can adapt that, right? And many can be hard to set up. I mean, it's fact, right? So you have to actually work hard to find a way to set it up. Many of these things, you might likely be the only few people that work on this particular framework. So it can take time. And that's the nature of it. There's no way you can evade that. It's required hard work. You want to read papers that describe the framework to make sure that you know exactly what you're doing with the tools, right? And you want to figure out the scope of things you need to do to test your idea, because at the end of the day, you need to finish your project. So if you keep reading, you're not going to finish your project. So you want to find a scope. If I know this much, that's enough for my experiment, so I'm good to go, right? So that's it. Basically, that's it. Remember, everything should be backed by science. Everything is going to be backed by science, because that's the, like, whatever I would call it, closer to the truth as possible, right? As long as you can prove that. And it requires hard work. So this is something I have to stress with all of you here, because you are going to have to deal with new tools that have limited documentation, new knowledge. So you need to really have a good basic fundamental knowledge. I'll give you one example, right? My students can be getting stuck with some of the tools that have to actually, he actually have to use to do parallel programming, right? And it's not easy to to actually code that on your own, especially when you have to modify the tools, right? Not just modify your own code, but modify the tools. But it's something you have to do. It's the nature of it, right? So you can get stuck with that. So you want to do the following. You want to train yourself really hard and work really hard. You want to actually work hard, train hard, because you have to think about it this way. if the problem is important, there are going to be a lot of other people that are trying to work on solving this problem as well, right? You want to work hard and work fast, so you know what would work and what does not work as soon as possible. So you can either move on or find alternate solution really quickly, right? And somehow you occasionally would get stuck, right? It's the nature of good and hard problems. So deal with it. To be honest, deal with it, right? You can complain to your friends, and your advisor and your professors would all know that, hey, this is a hard problem. Awesome, keep working on it, right? We are supporting you, to be honest. Like, we are supporting you because I want you to work on good problems, but it's also required hard work. So if you want to give up early, I mean, it's your fault, right? So you want to make sure you don't give up. You need to be aware of the active problems, because generally, right, your smaller subset of problems that you're working on right now would kind of change over time, because you're gonna solve one thing at a time. So break things down. Don't look at the big problem at a whole all the time. That's depressing. Break the problem down so that you can solve one thing at a time. This would allow you to keep your sanity, because things are hard, right? And you want to be aware of all the tools that you use to help making things easier for you. But you also have to have the guts to create or hack whatever tools you need, right? This is basically something that you have to be able to do. And you have to be aware of all this related basic science. You have to be keeping up, and you have to keep reading. Some other hints, as I said earlier, when you read papers, be mindful of the method or methodology section from related paper, because that can provide clues into, hey, they use that framework, it seems to be working, can I try that? Download and try it. I mean, why not, right? And then try out their configuration and see if it works, right? You can even actually email the author of the paper, right? Because if they authored the paper and they saw the email asking about whatever they're trying to do, to be honest, that's a good thing. I have occasionally I got emails about the mechanism I put in for some of my paper, and I'm glad that they asked about it. It means they read my paper, right? And they want to actually use my tools, right? So those are good. Those are good. And I actually, to be honest, I encourage you to do that as well, right? As long as it's not too old. For example, it's a 20 years old paper. I mean, it might be hard to contact the author, right? But most of the time you're gonna deal with modern tools and like tools that from like 1 or 2 years ago, right? So you should be able to contact them. You can also the next step is, like, now that you're trying to prove your hypothesis, you need to be able to analyze your data. This is the initial results. Then you want to look into, okay, does it support my hypothesis? If it is, why? Don't just stop at, hey, support my hypothesis. You need to be able to answer why. Don't just go to, hey, it performed better and done, right? You need to go identify why things behave the same way that you observe. Most, if not all, great paper do this. You want to be able to explain why things get better. Have secondary set of data to back it up. Anything else you can do to make the case stronger? Anything you can do to help making sense of what the result is behaving, right? If it does not, why not? What goes right and what goes wrong? So that would give you a small clue on how do I troubleshoot this problem, right? And let's say you're done with this. You have some motivational data. What's next, right? Well, hopefully your analysis at least leads to some clue on what went wrong with previous works and what can you do to improve the paper. If not, then rinse and repeat, learn from your failure. That's when I said fail fast and fail really, learn from it, right? If it is, then the next step is start addressing the problem. Remain by that. Then you keep improving your hypothesis, because the next step is to develop the hypothesis to solve the problem. What will prevent the problem from occurring? What would further improve your proposal and reach the better goal? And can we go even further than your original goal? And my recommendation is super high level, so it's close to useless, to be honest, but I have to repeat it again. More reading, more thinking, and more discussion among your peers. Talk to your friends. You might be surprised they might give you a really great idea as well. Think about it this way, people, especially people who are taking classes with you, I mean, they have the same knowledge to some extent with what you have right now, right? So it's good to kind of exchange these ideas. Talk to your peers, like your advisor, and a professor at TGGS, people worldwide, right? This discussion would help when you want to develop a better solution, because now that you have some clue, the assumption is you know what the cause of the problem, you know what should be changed to improve that. But how can I actually make this change, right? That's when you start to design your own solution. And I want to make sure you are creative about it. This is one of the downsides I saw in many of our students, where you got stuck with certain mechanism. And even with some feedback to say, hey, Fong, I'll give you one example, right? There's some computation that a student in EPE always loves to claim that, hey, that's a really complex matrix multiply that you're doing in MATLAB. And I'm like, matrix multiply, use the GPU, is fast, much faster. Like, why not, right? And I haven't really seen anyone actually follow that up, right? It might be a stupid idea, who knows, right? But to me, when they say, hey, matrix multiply, which is a really known math operation, we know how to make it fast. And I'm basically giving advice on how can we make it fast. I'm like, why can't you just learn how to program on a GPU? It's not that hard, right? I mean, it's hard to some extent, but to do matrix multiply, that's not hard at all, right? So be creative about a solution. That's when discussion comes into play. That's when you might want to try new things. I mean, the worst case is you learn how to program with another language, or you learn how to program using a different devices, or you learn a new math trick, right, that you can use for another project. I mean, it's good. And then let's say you have this solution. You want to think of what are the trade-off of my design, because most design and technique have trade-off. So you need to ask, like, what do you gain from the design, and what are you losing? What's the overhead of the design? And is that trade-off reasonable? If it's not, can you reduce the overhead somehow? Can you engineer your solution so that it becomes more cost-effective, right? So my tips is, again, solution from other area or unrelated problems might work really well with your specific problem. So that's when keep reading helps you, right? And now let's say you have a solution, then the next step obviously is you need to evaluate your solution. How do I do that? Well, first you list what you want to deliver out of your design. And then you list the potential downside of your design. Then you can start to conduct your own experiment to show the benefit of your design. And this is basically where I get really hand-wavy, right? Because this is a class for both electrical engineering, computer engineering, communication engineering, and to be honest, this is more like an art rather than like a fixed steps that you have to do. So you need to basically think logically and see how can I prove each of the points in my design. Right? Most of the time, it involves things like running things in MATLAB, running code in C, running code in Python, making sure you set up the baseline, basically set up the state-of-the-art baseline, the best baseline that you know from literature, and compare your solution with that. Then you are going to measure things like performance. Your primary set of data should directly address the problem. That's the primary set of data. If you want to aim for better performance, basically, I want to design fast computer, your primary data, how fast is my new design? If I want to design another cost-effective way to send data in 5G, have a baseline as the current modern day state-of-the-art 5G and look at things like energy consumption, packet loss of your design compared to the baseline. That can be your primary set of data, right? Then your secondary set of data should support your hypothesis and your primary set of data. Think about it this way. What would an adversary ask here? If I'm your enemy, How can I attack, right? How I can attack your data? Because then your secondary set of data would back my data up. It would back my proposal up, right? So let me go through a really high level example, right? So let's say in the evaluation, I can try to build an experiment that would give you the first set of plots that would show how your designs achieve your goal. And let's say, hey, the performance or improvement is awesome. Then, if you have any secondary goals, you should show and design the experiment to show the secondary goal. Right? Then you would do the detailed analysis on, hey, with those awesome number performance improvement, where does that come from? What part of the system perform better such that the whole big system is better than the baseline? These data would back up your main plots, right? Then you need to provide the data if the design incur any overhead. How much does the design cost? To be honest, again, I've rejected paper that looks promising, but the design seems to be costly and they haven't really evaluated the cost of their design because that can kill the idea. It's just too costly to build, right? And then you should try your best to show the robustness of the design. Can I work with multiple types of applications, different configurations, different scenario that can occur? Does it work there as well? So these are a good way to keep improving your project, right? Your research. And once that's done, the next step is to evaluate the overall proposal from front to back, right? So now that you have full list of ideas, check your evaluation. Are those correct? Does it make sense? Reiterate everything because sometimes data conflict with each other. It can point to like bugs in your code, for example, right? And does it achieve your original goal, right? Does it expose any interesting follow-up idea? And list what you've learned. List what you've learned and ask this question. Can I improve things even further? Can I create an adversary to attack my idea or attack the data I'm presenting? Can attack my setup? If anything here is a yes, then keep improving. Repeat, identify the new set of problems and repeat the experiment to improve your idea. So the goal I want to leave you with like, hey, strive for the best ideas possible because most of the great paper would have a lot of novelty. And what does it mean? It basically means that is a problem new? Is analysis new? Is the design fundamentally new and different? Why is it different from a previous design? Do I change the way I think? Can I read this paper and now I change the way I think completely? To the same problem even, right? But I change the way I think. Does the paper contribute to anything new? Because your paper, when you write a paper, you have to answer yes to at least one of these questions, right? And let's say this novel, yay, right? You found your own project. You are basically now writing. I will kind of wrap it up with something on the side, like the publishing process, because this is something that many of you here are not familiar with. So I want to kind of briefly talk about it. So let's say you submit a paper. This typically would happen. Hopefully the expert, right? The reviewer would review your paper. The reason why I said hopefully is sometimes the venue that is in the third tier, fourth tier venue, you are not likely to get the really like a world expert to review your paper. But when you submit a paper to good venue, you actually get a really, really good feedback, right? You must address these thoroughly. You must address all of this, right? Because if you address it and you are likely to get the paper accepted, then you prepare the final version. Sometimes we call this camera ready version. And if the paper is not well written, this is like the last time to fix English, so to fix your English, and make sure it's as perfect as possible because good writing goes a long way. Good writing goes a long way. And then the paper is published, and yeah, right? So well-written paper will have a much, much, much higher impact. And then I'm gonna ask, leave you with this: the question you always want to ask. right? Is this the best solution? Let's say you publish a paper, like are there any alternative solution? Are there anything you can do to further improve the system further, right? Can you explain every single things on the paper? Why does my result behave in a certain way? Is it kind of repeat the same step over and over again? And generally, it's always asking why, right? This one word is so powerful in research because it will give you a way to think whether thing makes sense or not, and always be curious. And this applies to everything, right? Because when you submit the paper, a good reviewer would ask a lot of the why question, especially if you don't have things that you can explain. They're gonna ask why, and they will keep on asking why until you can explain it, right? And that's it for the main bulk of this particular video. Before we leave today, I will have like some of my advice on research, right? Uh, what I found is like finding a good research problem is actually really, really, really important, because once you have a good problem, you're kind of set to at least make an impact as long as you can fix the problem, right? And you could find the true cause of the problem. That's also really important because that would fundamentally allow you to think, if I can get rid of that, I'm good, right? So it's make the goal a lot more clear. And with that, focus on the goal, because there's so many problems in the world, right? So once you set out for the goal, focus on the goal and don't spend time solving things that doesn't really solve whatever you set out to. Keep it aside. You can work on it later. Fix one goal at a time. And no one is always right. Even laws can be challenged. So discuss your idea and trust in science, right? Trust in science and be very rigorous, right? And you want to be able to manage your time well as well, right? The research does take time and you want to plan things ahead of time. And you should be able to explain everything on the paper that you're writing. What else? You want to brainstorm and discuss your ideas among your peers, your friends, other professor, and expert that you might know, right? And keep reading and learning, right? And that's actually it, except for I want to live with the class project. Like, what do I really want for your class project? Your research, right, should provide contribution. So we're gonna focus on the novelty. The purpose of this project is for us to provide feedback, and hopefully you can improve on the idea, right? So make sure your problem is new. If it doesn't sound new, I'm gonna definitely ask you what's new about this. Why haven't anyone solved it? And you want to be answer why. You should also have a presentation and a project that scientifically makes sense, because we're gonna check for correctness. We have a lot of resources in terms of human resource, your advisor, the other professor in the program. We are here for you. We can brainstorm. We are human. We can talk, right? So even when you're not our advisees, feel free to send us an email and come talk to us. We are more than happy to brainstorm different research idea, right? The worst case is, hey, that problem seems solved. Like do something else, right? I mean, that's the worst thing that can likely I guess potentially can be the worst thing. But at the end of the day, you're gonna basically go on a faster track to wherever your goal is, right? And you want to be really rigorous, right? I know you have other classes, but do this the best way you can and push your limit. Because if you don't push your limit, right, you're gonna face competition in the job market as well, right? So make sure you work hard, right? We can tell when you submit something sloppy, and it's always saddened me to see that. Don't do that. I see great work and I see sloppy work. It's so obvious, right? When you're sloppy, and your grade would tank because of that as well. That's like a side effect, but you want to actually try to push your limit and work hard, right? And that's it for this particular video. Next lecture, we'll start to talk about basically paper writing. So it'll be a continuation of this particular topic, but now it's more on the writing aspect and how to present your idea on the paper, right? followed by research ethics, which I will talk about things you should adhere to, some guideline and things you should not do. All right. So that's it for this video. Thank you so much for your time.